So we have here the Enterprise Miner, a diagram that has been used to compare a decision tree and gradient boosting for police data, South Wales Police, for March 2017. The data is publicly available. The intention of this video is to present the method and the results and to discuss them. The file was imported, it was a CSV, so it was turned into a SAS data table, converted, and then it was filtered to such that the crime type field was filtered to only contain the values that have an occurrence of over 1,000 in the data set in this crime type field. The data was then partitioned, 40% for training, 40% for validation, 30% for validation, and 30% for testing. And so then a decision tree was built using the inputs. The target was crime type, the target classes. The inputs were the LSOA code, or lower level super output area, which is a geographical area that is used in statistics by the government in England and Wales, and the last outcome category, which is the current status of the investigation of the crime or prosecution, depending on whether a suspect has been found. The results of the decision tree are seen here. We can see that we have a very similar misclassification. It's around 11% for all. The testing, training and validation are very similar in misclassification, therefore we can assume that the model is fairly general for the data set. There were missing values only for last outcome category, categorizes antisocial behavior very, very well. This appeared to be a data entry policy for the force in question, while criminal damage and arson and violence and sexual offences seemed to have had a very low incidence of missing values in the last outcome category. The most interesting node is the second node that splits between a majority leaf criminal damage and arson and a majority violence and sexual offences. The rule is whether the value in the last outcome category is investigation complete, no suspect identified. This is quite significant because we can see that criminal damage and arson is much more likely to have no suspect identified than violence and sexual offences. This isn't a surprise because by the nature of criminal damage and arson, it can be done without the knowledge of the victim, while violence and sexual offences, it is much more rare for the victim not to have knowledge of the crime, and the offender is very likely to be present at the offender is by nature present at the same time as the victim at the crime scene. Then I used the filter data to carry out a gradient boosting of a decision tree algorithm, 50 iterations with a sample proportion of 60%, and the two models were then compared. So we see the results here. The most important, remember that the misclassification rate was very similar for all in the tree. So when we compare only the training misclassification, we are able to compare all of the misclassification rates, and as we can see, the boost here is the gradient boost is much higher, much lower in misclassification, about 1% lower by rate than the tree, and therefore we can say that the boost is more successful at producing this predictive model for this particular data set.